More on this, I want to bring in Sienna Aerospace analyst Miles O'Brien, and also lending us his expertise is former NASA astronaut Garrett Reisman. Thank you so much for being here, both of you. Garrett, I want to start with you. I mean, you've been on a couple of spacewalks before, so many unknowns and these further delays now. So take me through the mindset of the astronauts as they wait. I mean, how nervous would they be, do you think?
I don't know if I'd use the word nervous, but they're excited. They're super excited. I remember before my first spacewalk, my heart was racing and I was just super hyper aware and focused. You're about to do something that's one of the most incredible life experiences, and the anticipation can really get to you. Just waiting for that hatch to open felt like it took an eternity, even though it was, just a matter of minutes. So it's a super exciting thing they're about to do.
Yeah, and so I mean, what is that moment like when you pull yourself clear of the vehicle and into space?
When you first go out there, it's this surreal combination of the familiar and the outlandish. And what I mean by that is that the suit fits exactly like the one in training. Your tools are exactly the same as the ones you've been working with on the ground. The bolts are right where they said they would be. Everything that when you go outside is exactly how you expect it because their training is so good. But then you look over your shoulder and you see the entire east coast of the United States go flying by at 17,500 miles an hour, and that you didn't see in training, and nothing can really prepare you for that.
Wow, unbelievable. Listen, I want to go to you now, Miles. So our reporter Kristen there talked to us about some of the differences that we've seen with other missions. This one, they're plugged in as well via the umbilical cord, essentially, literally a life-giving mechanism there. So take us through some of the differences about this spacewalk from what we've seen before.
Yeah, Kim, just listening to Garrett, I don't understand how anybody gets any work done on a spacewalk with that view, but we'll put that aside for a moment. This actually harkens back to the first spacewalks in the 1960s, the first U.S. astronaut to do it, Ed White, Alexei Leonov of the Soviet Union in that same time frame. In both cases, they had to evacuate all the air from the spacecraft and were attached to the life support systems of the spacecraft with umbilicals, which is what is going to happen in this case. So it's a stepwise kind of thing. The spacesuit that Garrett wore, the EMU, Extravehicular Mobility Unit, has a backpack on it which allows the spacewalker to be untethered, although they hang on pretty tight to the space station, of course, and in other ways are attached. But it has its own complete life support system. It's a mini space craft. And what Elon Musk and SpaceX are attempting to do here is make these suits a little more less expensively. It's about a $15 million suit on the NASA side. And if Elon Musk and SpaceX are to achieve their goals of sending armadas of spacecraft and people to a place like Mars, they're going to have to drive down the cost. So part of this is this first step of understanding what these suits are like. And so for the first one, it's a good idea to stay attached.
Yeah, and staying on that spacesuit, I mean, they have said that obviously, things will be improved and so on and so forth, but this could be basically an iteration of what we might see humans actually wearing on Mars.
Yeah, and it's not an easy engineering problem when you think about it. Garrett can attest to this, that when the suit is pressurized, it kind of blows up like a balloon, and the mere act of closing your glove can actually, cause you all kinds of problems and blisters and so forth. So you have to find the sweet spot between pliability, flexibility, having joints that operate in a way that you can do some work, and still protecting the human being from the void. I mean, we're talking about huge temperature swings, many hundreds of degrees plus and minus, whether you're in the sunshine or on the dark side of low Earth orbit. And you have to prepare for that, and you have to make sure that the astronaut is protected in every way. So this process of learning how to build with that kind of, sort of rigidity and yet pliability, if that makes any sense at all, is what they're after.
Well, staying with you, I mean, this success by SpaceX is in contrast with what we've seen from the Boeing Starliner. We saw that problems with its thrusters meant its return was delayed for 3 months and just came back now without the astronauts that it was meant to carry. So a real contrast in perception here if this is successful.
Yeah, I mean, SpaceX continues to overachieve. If you asked me 10 years ago, Kim, which of the two contractors selected to fly spacecraft to the International Space Station, which of the two would succeed soonest, I probably would have bet on Boeing, which has historically been involved in space missions with NASA since the beginning. But that obviously is not what has happened. This is, I think, the 14th crewed mission of a dragging capsule. 14, and Starliner, as you know, ended kind of ignominiously without anybody inside in New Mexico just last week. So space is hard, and NASA is dealing with all kinds of issues of funding, brain drain. A recent report just came out, somewhat scathing as to whether the agency just has way too much on its plate relative to the budget it has, and so. There's a lot of issues that are dragging down NASA, and meanwhile, SpaceX seems to be flying high.
Here, I want to ask you about this. I mean, there are so many things to be looking for as we sort of watch this take place, including how the vehicle itself will deal with depressurization and being exposed to the vacuum of space. Take me through what you will be studying as we watch this coming up in a couple of hours.
Well, it should take about 2 hours total from depressing the cabin to repressing it back up again. So it's going to be fairly quick compared to the spacewalks that I did and that we do on the space station, which typically last over 7 hours. In fact, we have about 9 hours worth of consumables in that suit, as Miles pointed out. And it is quite different because it recycles the air, which is why we have so much more time. These suits that they're using are open loop suits, so you have to constantly feed them with fresh oxygen. And the moment you start doing that, you're on a clock. And so it is a bit of a nail biter. And I would say that actually the risk involved in this spacewalk is higher than the risk I faced on my 3 spacewalks. So I'll be watching them. They're not going to do anything terribly difficult from a task perspective, but it has to go right. And there's not a whole lot of room for error because of this issue with the suits, because of the difference there.
That's fascinating.
So I'll be watching them. I'll be. Look, Sarah and Anna are good friends of mine. In fact, I hired both of them at SpaceX to work there. And until they get back inside and repress the capsule and have that hatch closed, I'm going to be a little nervous, to be honest with you.
Yeah, I imagine so. You and the families and everybody else who will be watching. I hesitate to ask you this since you are friends with them, but you talked about the risk being higher now. I mean, what would your biggest worry be?
Well, I think the suits will do just fine. They've been very well tested in vacuum chambers on the ground with people inside. In fact, with these crew members inside of them. Their training is excellent. I think the crew is very well prepared. And what they're attempting to do is not physically terribly difficult necessarily. So I'm feeling okay about all that. It's just that things during spacewalks often don't go exactly as you plan. Things happen. It's difficult to work in suits like that. And just opening and closing hatches can be difficult. And when we have problems and you have 9 hours to deal with them, that's one thing. If you have a problem here and you only have minutes to deal with it, that's a bit more of a high wire act.
Miles, we'll end with you. Assuming this goes to plan, everything works, what happens next? Take us through the trajectory.
Well, the mission is a 5-day mission, and as we said, there is another opportunity for a spacewalk if they can't get this all to work and feel comfortable about going outside. So there may be another chance at that. They'll continue a series of experiments. They flew to a very high altitude, surpassing an altitude record set by Gemini 11 back almost 60 years ago. That gave them a dose of radiation. They're trying to understand the radiation environment for any crew that heads out to Mars. It's an important issue that needs to be addressed to protect a crew from the radiation which exists in space. And then subsequent to the spacewalk, they're going to test out a communications system that hasn't been tried in space before, Starlink, also an Elon Musk company. They're actually above the satellites, which make that satellite-enabled communication system work, and they'll use a laser scheme to try to communicate with it. Yet another thing that's important if you're serious about colonizing the moon and Mars is you want to have some good bandwidth as well. So they'll step through those over the 5-day mission and hopefully get this historic spacewalk done before too long.
All right, we'll be watching. We're expecting it in about, 3.5 hours from now. Miles O'Brien and Garrett Reisman, thank you so much both for being here with us. Appreciate it.
My pleasure.